Alright, now that we know how to find the slope, we would like to find an equation of a line. To find an equation of a line, we need a point and a slope. The point is given all the time. Generally speaking, the slope is something that you have to find always. That's why we found the slope first. And once you have the point and the slope, you have two options of finding an equation of a line. Either you use the point slope form, which is y minus y1 equal the slope m into x minus x1, or you would use y equal mx plus b. You need to find m and b in this case, and here you just plug in the point and the slope. So to follow on, we're going to look at the first batch of problems, and here we are. Assume that we do have the slope and the point. We would like to practice and make sure we get this. Find an equation of a line that passes through the given point, has the given slope. So if I use y equal mx plus b, I could do that. Again, either of those will do. This is a special case because this is the point 0b. So if x equals 0, that's b automatically, which tells you what this is. And if you're not registering that or you're not there yet, that's okay. Let's do it the long way. The slope is 2/3. So y equal 2/3 x plus b. And now I still need to find b. I always have to find those two. That's where the point comes in. This is x, this is y. So y equal a 0 when x equal a 0. And that means 0 equal to b. So here I'm getting y equal 2/3 x plus 0, just 2/3 x. And that's how it would look. If I want to sketch a graph of this, the graph, we already know how to do this. I have a point, there's a point, and I'm gonna rise 2 units, and I'm gonna run 3 units. Connect this with a straight edge. There's my line. Done. That's simple. If I look at this equation, y equal mx plus b, I notice here the slope is 0, and then I do remember something about a special case which says if the slope is 0, you have a horizontal line, and the equation is y equal a number. If I can remember that, that'll save me a lot of work, meaning y equal a number. Well, where do you think y is? There is x, there is y, so y equal 4 would be the equation. Keep in mind, if you are to say y equal mx plus b, that will still work. You would say y equal m is 0x plus b, so y equal b. And if you plug in the x and the y, there is no x, but you're going to replace the y by a 4. So this would be a 0 in there and a 4 in there will give you that equation. But you could save yourself a lot of work by just doing this. As far as the graph is concerned, it's fairly simple. All what you have to do is go up 1, 2, 3, 4, draw a horizontal line at y equal 4, and there it is. Make sure you label the x and the y. And if you don't really mark those, I assume it's a 1, each one of those. And if I look at the last problem, the last example that I have for this section, for this set of problems, I'm sorry, number 58, I notice, again, for the graphing, I do want to point out, I don't need anything. If you give me the slope and a point, if you give me the point to be -1, -1, -2, -3, -4, a slope of -2 over 1, so I'm going to run 2 units down, 1 to the right, I could really sketch a graph. So I don't want you to mix finding the equation with the graph. That is sufficient for me to sketch a graph. Find an equation of a line. You could use y equal mx plus b, or you could use y minus y1 equal m into x minus x1. The book is more geared toward this, that's why I'm using that more. in case you look at the examples. So this is saying y equal m is a negative 2 x plus b. I still need to find b. That's where the point comes in. That's an x and that's a y. So y equal a negative 4, when x equal a negative 1, negative 4 equal 2 plus b, subtract 2 from both sides, b equal a negative 6. So the equation for this line is really y equal negative 2x minus 6. There it is. Now, on the next set of problems, the same deal again. It says find an equation of a line passing through the points. Then sketch a graph. Well, again, to graph the line, negative 2, 4, negative 1, negative 2, negative 1, negative 2, negative 3, negative 4, there's a point, and 1, 5, 1, 2, 3, 4, 5. Connect those with a straight edge. There's my line. I really don't need anything else. 2 points are more than enough. But for me to find an equation of a line, I would need a point and a slope. I'm given 2 points. I know how to find the slope given 2 points. That would be y2 minus y1. y2 minus a negative is a positive. x2 minus a negative is a plus 2. The slope would be 9 over 3, which is 3. I have a slope. Now I have 2 points. I could pick either point. I'm going to pick this point. I'm going to say y should equal mx plus b. mx plus b. All what I need to do is find b. So if I substitute 1 for x and 5 for y, 5 equal 3 times 1 plus b. There's the y. You could use this point, it doesn't matter. So this is 2 equal to b. That means the equation is y equal 3x plus 2. Same deal here. Now I notice this is big. So I scale this by, I could say that's a 2, 4, 6, 8, 10. 1. So I could rescale this any way I want. And 6, 1, 2, 4, 6, 1. If I connect this with a straight edge, what do I notice? Once I notice that this is a horizontal line from the special cases, I know for a horizontal line it's y equal a number. And which of those y's do you think I should pick? Well, it doesn't matter. You're done. And if you didn't see that, you would have to figure out the slope and do all of that. But once you see it's a horizontal line, or if you say, you know what, let's find the slope, y2 minus y1 over x2 minus x1. So if the slope is 0 over 4, which is 0, once you see a slope with the 0, those special cases are all over the place. Once you see the slope is a 0, you should know the equation is y equal a number. And if the slope is undefined, the equation is x equal a number. You need to know those. And if I look at this graph right here, 2, 5, I notice the y's are really big, so I'm going to go by a 5, 10, negative 5, negative 10, and 1, 2, 2, 5, 2, 5 is right there, and 2, negative 10 is right there. And when I connect this with a straight edge, I realize that this is a vertical line. For a vertical line, x equal a number. Which x should I choose? Well, guess what? You can get it wrong. And if you decided to find the slope and say that's negative 10 minus 5 over 2 minus 2, you're going to get negative 15 over 0, and that's going to tell you the slope is undefined. If you could recognize that quicker, you really don't have to do much work. Now, last thing we need to discuss, parallel lines and perpendicular lines. We say two non-vertical and non-horizontal lines are parallel if the slopes are equal, and they are perpendicular if you multiply the slopes and get a negative 1, or the slopes are negative reciprocals. Special cases. Any two vertical lines are parallel. So any vertical line is parallel to any vertical line. Any horizontal line is parallel to any horizontal line. And any vertical line is perpendicular to any horizontal line. So any line looking left to right and vertical, that's automatic. Any two vertical lines automatically are parallel, and any two horizontal lines are automatically parallel. So when I look at the next problem, find me an equation of the line with the given characteristics. I want a horizontal. Find me an equation of a line that is horizontal. Well, isn't a horizontal line y equal a number? And what's so special about this line? Well, which of those is y? There it is. That's all you have to do. And if I look at these problems, find an equation of a line that passes through the given point, this point, this point, or this point, and are in part A parallel to this. Well, given an equation, how do you find the slope? Don't you solve for y? So that was the last homework. That's why I split this into two parts, to make sure that we get the slope out of the way before we get this far. So as far as this problem is concerned, oops, but too far, the slope of this line is negative 2. I must have a y by itself on one side, there's the slope. So in part A, I want it parallel. What do I know? The slope is equal and the point is 2, 1. I know how to do that. I could say y equal mx plus b, that's part A. Well, I just like to find b, that's where this comes in. Y equal 1, when x equal a 2. B equal a 5. So this equation is really y equal, this equation becomes negative 2x plus 5. Part A is done. Part B, it's the same idea. Alright, now I'm gonna look at part B and say, well, in part B, let's see how this works. I want in part B the line to be perpendicular. The point is still 2, 1, but if this is the slope, I know perpendicular lines will have negative reciprocals, so m will equal, multiply that by a minus and take the reciprocal. There's the slope and there's a point. And I could say y equals 1/2 x plus b. There's the y. X is a 2. 1 equal 1 plus b, so b is 0. So I could say y equal 1/2. You could write plus 0, but normally we don't do that. There it is. Now, here, again, in part A, I want parallel, and in part B, I want perpendicular. Well, I notice this is y equal a negative 4. Y equal a negative 4 is a horizontal line. That's a special case. A line that's parallel to a horizontal line is a horizontal line, and it has to pass through that point. Well, equation for a horizontal line is y equal a number. Which of those two will be the y? That will be the 5. Done. And a perpendicular. I know a perpendicular line to a horizontal line is a vertical line. And a vertical line has an equation x equal. And isn't that the x? Again, it's right there. Two horizontal lines are parallel, so if you have a horizontal line, a line that's parallel to it would be horizontal. And a horizontal line and a vertical line are always perpendicular. If I look at number 82, I solve this equation. This is x equal 5. I notice that, wait a minute, this is a vertical line. So in part A, when they say, find me an equation that's parallel to this, well, in part A, I must be dealing with a vertical line, but the line that I'm looking at must pass through this point. An equation for a vertical line is x equal a number. And which of those two will be x? The 12. And when I look for a perpendicular line, we just said if you have a vertical line, a horizontal line is perpendicular to any vertical line, and we know from the special case that a horizontal line equation is y equal a number, and it has to pass through this point. Isn't that the x, and the y will be a -3? And that will take care of this. On number 88, personal income, I think they wrote that twice. Personal income in billions of dollars in the United States was 12,430 billion, right? So in the year 2008. Anytime you're dealing with years, you want to think of it as your birthday. So if you were born in 2008, in 2012, you say, wait a minute, I was born in 2008. Assume t equals 0 is 2008, right? That's normally how we do it, except they tell you what to set it equal. So if they didn't, if they would not have set anything up, I would have assumed that this initial point is 0, kind of like your birthday. But here they say, in 2008, it was 12,430 billion. In 2013, it was 14,167 billion. Assume that the relation between the personal income, y is the personal income, and the time in years is linear. That means it fits in a straight line. Let t equal 0. So they're saying let t equal 0 resembles the year 2000. All right. What does that mean? Well, let's see. That means in 2008, so from 2000 to 2008, in 8 years' time, we had 12,430. And if t equals 0 stands for 2000, then in 2000, if somebody was born in 2000, in 2013 they'll be 13 years old, and that would be 14,167. I have 2 points. I want to find an equation for the line. To find equation of a line, I need a point and a slope. I have 2 points. I know to find the slope given 2 points. I'll take either point. The slope will be y2, 14,167 minus y1 over x2 minus x1. The slope would be, the denominator is 5, this is a 7, a 3, 4 out of 11 is a 7, 2 out of 3 is a 1. And I could leave it like that. And to find the equation of a line, I'm going to say y equal mx plus b. And I already know what I need. I need the slope I already have. I need b. So the numbers here are never nice because this is actual applications. You could use a scientific calculator. I'm going to take this point. I'm going to say 12,430 equals the slope 1737 over 5 times x. X is 8 plus b. So I'm going to take my calculator out. You should get a scientific calculator. Here we go. I'm going to take 1737 multiplied by 8. Okay, I made a mistake, obviously. If I take 1737 times 8, I'm getting that value, right? And if I divide it by 5, I'm getting 2779 point, I forgot, 0.2. Again, it's okay to use a calculator. And if I subtract that from both sides, if I make that negative, there it is, and add to it 12,430, I will get 9650.8. Be careful with the decimal because that's in billions. So my equation is that y equal m is right there. And you know what? Might as well. Let me get m. If I take 1,737 divided by 5, I'll get 347.4. 347.4. I didn't mess that up, right? Yeah. So this is 347.4 x or t in this case, right? Because t is taking the place of x, plus b 9650.8. That's, tell me the year, I'll tell you the income. That's part A. If I look at B, it says estimate the personal income in 2011 and 2014. Well, 2011. Remember, t equals 0 is the year 2000. So this person was born, think of it that way. In the year 2000, they were born. I want 2011 and 14. 2011 and 2014. Well, if somebody was born in 2000, wouldn't that mean 11 years have lapsed? So in the first case, and here, wouldn't that be, if they were born in 2000, in 2014, 14 years have lapsed? So how would I answer this? Well, in the first part, I'll say, look, y equals, and there's the equation, 347.4 times 11 plus 9650.8, y, and remember y was the income in billions. And now it's a matter of me having my scientific calculator and using that properly. So if I take this and I take 347 point, okay, good, times 11 plus 9650.8, I'm getting 13472, 13472.2 billion. And if I go by the 14, y would equal 347.4 times 14 plus 9650.8. Y would equal, again, a calculator problem. If I take 347.4 multiplied by 14 and add to that 9650.8, I'm getting 14,514.4 billion of dollars. Alright, now part C we're going to ignore because let's go to the library. With COVID and all of that, we don't do that stuff anymore. And one more to go. This is important. Linear regression is when you lose values. Something like you buy a car, you buy it for a certain price, every year the price goes down. You buy a cell phone, every year it goes down, a new laptop, all of these things. A hospital purchases a 500,000 magnetic resonance imaging. That's an MRI machine. It costs $500,000. That has a useful time of 9 years. They could use that just for 9 years. The salvage value at the end of 9 years is 77,000, which means they could sell it and the company could take parts of it, salvage some of the parts, but they will pay the hospital $77,000. So I could buy it now for $500,000, and 9 years from now I'm going to sell it back for $77,000 or lose it, either or. A, write a linear equation that describes the value. Y is the dollars in terms of the machine. Well, let's see how this works. Right now, so I know that at t equals 0, so right now it's going to cost me $500,000. And I know 9 years from now it's going to worth $77,000. Find an equation of a line. I have 2 points. Not only that, I have the y-intercept. That's an easy point. So I have, out of those, y equal mx plus b. I need the slope. Out of those, the slope is y2 minus y1 over x2 minus x1. If I throw this in my calculator, I will get 77,000 minus 500,000 divided by 9. Negative $47,000. So this machine is going to lose $47,000 every 1 year. That's what that means. It's over 1, right? The number of years. Every 1 year, it's going to lose $47,000. Notice that I have the y-intercept, so this is b. So the equation here is y equal, and they like t instead of x, not a big deal, because this is t, this is y, this is t, this is y. Y equals negative 47,000 t plus 500,000. And if you're not seeing this, you could use y equal mx plus b, and you would notice really quickly if I replace y by 500,000 and t by 0, right? I will get just b, which is 500,000. Again. Now, part B. Find the value of the machine after 5 years. Okay? If t equals 5, what does the machine? Well, this is the value of the machine. That will be negative 47,000 times 5 plus 500,000. This is part B. This is part A. And I'll get my calculator again. I'm looking for, so negative 47,000 times, times 5, and add to that 500, 1, 2, 3. It's going to worth $265,000. And in part C, they say, all right, find the time when the value of the equipment is 160,000. So they're giving me y, they're asking me for x, so to speak. So this is the equation. If they want y to be 160,000, that's a linear equation. I know how to solve those. So what I do, I would, again, subtract 500,000 from both sides. So take 160,000 minus 500,000. That's negative 340,000. And if I divide both sides by negative 47,000, I will get t to be, so if I divide by, divided by, a negative 47,000. Oh, I messed it up somehow. Okay. Well, the answer is going to be positive, right? If I take, I should have brought my other calculator. Here it is. This is better. This is a scientific calculator. If I take 340,000 divided by 47,000, I'm going to get 7.23, roughly 7.23 years. And that's good enough as an answer. Let me give you the homework. And there's your homework.